Hello, we are the GreenLight Bioscience team, and we would like to introduce our Databricks GenAI World Cup submission, AdaptiveFilters, image processing agent. The contributors for this project are Mihir Kestur, Mateusz Grobelny, Lawerence, Upendra Devisetty. The next wave of innovation in agricultural biotechnology, poised to significantly impact sustainable agriculture, is the identification of novel biocontrol agents. GreenLight Biosciences leads in the field of biocontrol agents with the first of its kind bioinsecticide, Calanta. Identifying new biocontrol agents provide farmers with more options for managing challenging pests and reduce the use of chemical pesticides, which pollute the environment and linger on food products. Developing biocontrol agents is a lengthy process. Candidate agents must first be tested in the laboratory, then in the greenhouse, and finally validated in the field. This time-intensive development pipeline is set for disruption with the advent of generative AI technology, which can accelerate automated biocontrol agent screening in the development process. AgBiotech companies like GreenLight Biosciences use image capture and processing to identify and evaluate prospective biocontrol agents. Tasks such as disease monitoring, mass quantification, and automated field imaging can be performed via a high-throughput process, allowing for rapid assessment of new agents' performance. However, establishing a mature imaging processing workflow requires significant investment and expert personnel, which may not be feasible or available during the early R&D stages, such as initial laboratory testing. This leads to a substantial backlog of unprocessed images and considerable amount of time spent on manual image processing. As a result, scientists without expertise in image processing often have to manually process images to assess new biocontrol agents.
So to address these challenges, we would like to introduce the AdaptiveFilters image processing agent. Our solution leverages GenAI to help users quickly develop image processing pipelines. Users provide an image and a task description. The AdaptiveFilters returns a processed image, recommended filters, and the reasoning behind each choice, giving users a clear starting point for further customization and tuning. Consider this example. Given an image of a plant and a request to isolate it from its background, the AdaptiveFilters outputs the isolated plant image, recommended filters, and an explanation of each filters used. AdaptiveFilter is built on the Databricks platform. The image and the request are inputs to the LangGraph workflow consisting of 3 agents. The planner formulates a filter and a parameter plan. The executor applies this on the input image. The critiquer validates it against the user's request. If it is correct, the output is provided. If not, it is retried with feedback. Importantly, the planner is augmented with similar task plans using retrieval augmented generation. After each successful plan, the user's request is vectorized with the Databricks embedding model and is stored in the vector store along with the corresponding filter plan to assist with future planning. Let us now move on to the demo. So this is the UI for AdaptiveFilters, the image processing agent. And the first thing the user would do is input an image. So select an image and hit on open. So once the image is uploaded, I come down here and provide the task description. Isolate the green plant. Right, as you can see, once the processing is complete, we get the output from the agent. On the left, you see the original image. On the right, you see the processed image. It has done a good job in removing the background. And if we come down, we see an explanation for the choice of filters, and we also see a recommendation on what happens if we change the values. And our application also provides the ability for the users to manually change the filter values and see how it behaves in different values for the parameters. Let us proceed and ask it to identify edges. So the processing has been completed now, and as you can see, this is the output for a subsequent request of mine, that is to identify the edges of the plant. It has done a good job in identifying the edges. It has also provided the explanation for the choice of filters, and this time around it has added an additional filter, that is the canny edge filter, and the user can also experiment with the threshold values. I'm happy with this workflow. I can click this, store this pipeline. So now that I've clicked this button, the task and the plan is vectorized and stored in the vector store. So this is useful because it helps the planner agent to refer to these examples for future planning. Let's now talk about the key benefits our application provides. So for the end users, our application helps save a lot of time with intelligent filter recommendation. It provides filter rationale and parameter optimization guidance, and it also helps promote explainable AI app development. For the technical user benefits, basic image processing tasks can be delegated to the AdaptiveFilters app. The app can also serve as a platform for technical users to deploy proprietary filters for end users. And finally, the app can also act as a foundation for developing formal image processing pipelines. For the future development, we are focused on enhancing the variety and precision of filters, incorporate domain-specific knowledge, and leverage open source Hugging Face models that are easily accessible on Databricks for advanced image analysis. And finally, fine-tune LLMs with the task plan datasets collected for furthering the AI's ability to plan and apply filters effectively. Thank you. That concludes our presentation.